evening to all of you. Sorry for being late. Actually, okay, good evening. Okay, good evening. So, our today's topic is some special reactions of phenol. So, first and very important reaction of phenol is Raymond-Taman reaction. So, Raymond-Taman reaction. So, Raymond-Taman reaction, in this reaction, we have phenol along with chloroform and sodium hydroxide or potassium hydroxide. Yes. Sad, Yash, Swati, Ashish, Vasant, Sahil, Varun, Rishi, Harsh, Samir, and Kalyani, Dhavle, I don't know her. Okay, anyhow, welcome all. Wait. Hello. नहीं मत करो क्लास में. Okay. Okay, so in Raymond-Taman reaction, phenol is heated with, wait, I will keep it on silent mode. Phenol is treated with chloroform and NaOH. So on heating at 340 Kelvin, if you don't want to write the temperature, it's okay, just write the heat. Okay, so on heating we get orthohydroxybenzaldehyde or its common name salicylic. Okay, salicylic along with NaCl and water. Okay, so we get the product. Means this is the major product formed in this reaction. So what is the mechanism behind it? First of all, in chloroform, these are 3 electron withdrawing groups. All the 3 chlorine have which effect? Tell me, minus I or plus I? Yes. What is the effect of chlorine? What is the electronic effect of chlorine in chloroform? minus I or plus I, minus R or plus R. It is minus I. Very good. It should be minus I. Okay. Means these are electron withdrawing groups. Very good, beta. So when they withdraw electrons, which in turn withdraw electron from hydrogen, and that's why this hydrogen becomes slightly acidic. Now, in the presence of OH negative ions, because sodium hydroxide is there, so it will give OH negative. So this OH negative ion will get this hydrogen, and we get water along with this anion. Okay. Now, from this anion, Cl negative ion is easily removed, and we get dichlorocarbene. This is dichlorocarbene, and this dichlorocarbene is the reaction intermediate. This dichlorocarbene is the reaction intermediate. This is so what is carbene? When carbon has one pair of electron unshared, or we can say we have two unshared electrons and two bonds. That is called carbene. Okay. If hydrogens are replaced by chlorine, that is called dichlorocarbene. So keep in mind that in Raymond-Taylor reaction, when reaction is occurring with chloroform, dichlorocarbene is the reaction intermediate. Is it visible? Yes, it is. Got it? So this is the first and foremost step that will give you the reaction intermediate in a Raymond-Taylor reaction. Now, how this reaction proceed? See, first of all, phenol. You know, phenol, is it react with sodium hydroxide or not? Tell me first. This will react with sodium hydroxide or not? Phenol, when react with sodium hydroxide, we get sodium phenoxide along with water. And you know, phenoxide ion is more reactive than phenol towards electrophilic substitution reaction. Now tell me, dichlorocarbene, is it electrophile or nucleophile? Yes. Dichlorocarbene, is it nucleophile or electrophile? Very good, Sahil. Phenoxide ion is more reactive. So tell me, Sahil said it is nucleophile. Okay, nucleophile. Ashish, Saad. Now Sahil change the statement that it is electrophile. Samir, what? Yes, it is. Is it electrophile or nucleophile? Is it electrophile or nucleophile? Okay, Sahil said it is electrophile. Rest all of you. Okay. Now Ashish, electrophile. Okay. On what basis you can say that it is electrophile or nucleophile? Okay. Yes. So say, you know, in dichlorocarbene, this carbon has in dichlorocarbene, carbon has sextet of electrons. In dichlorocarbene, carbon has sextet of electron. It has 6 electrons, 2 from this CCl, 2 from this CCl, and 2 this. Means total 6 electrons. So it is an electron deficient species. Though it has unshared pairs, unshared electrons, okay, but it is electron deficient species. That's why it is an electrophile. Keep in mind, dichlorocarbene is an electrophile. Yes, so it is an electrophile. Very good. So now, as it is electrophile, it can easily attack on phenol, or when it is in the basic medium, it is changed into phenoxide ion. Okay, so phenol along with chloroform in the presence of sodium hydroxide at 340 Kelvin, you know, NaCl and water is removed, and we get sodium phenoxide and CHCl2. Now this CHCl2 and sodium salt, okay, it react with 2 moles of sodium hydroxide. So obviously this Cl is replaced by OH, so 2 NaCl are removed, so we get sodium salt and CHOH. Means it can be written as 2OH and 1H. And I have already explained, when 2 OH are attached to the same carbon, it is highly unstable and water is removed. Okay, so we get sodium salicylate and on acidification with HCl and NaCl is removed, so we get salicylate. Okay, now how do we approach up to this? So see, actually first of all we have phenol. It reacts with sodium hydroxide and we get sodium phenoxide and water is removed, and then chloroform will attack here. Chloroform, see, it is like this. Okay, so when chloroform attack, we get this product, because this pi electron pair moves here negative and this is lone pair, so we get CCl2 with negative sign. See, because two electrons are involved here, one electron of carbon is involved here, and it has one more electron, so it becomes like this. Because this pi electron transferred to carbon, so carbon gain the electron, so this carbon gets negative charge. Okay, so now this whole thing is unstable because here it is aromatic, this becomes non-aromatic. So to regain aromaticity, this is actually sodium salt now, this sodium, then H plus ion from here, that will again form CH and Cl. 2Cl and this negative gain this positive H plus, so we can CHCl2. So this is the intermediate formed here. Okay, so this is formed from this reaction. Okay, and then we proceed like this. Is there any doubt? Please do ask. So first point is, what is intermediate in Riemann-Dammann reaction? So that is dichlorocarbene. Now dichlorocarbene, what is it? It is an electrophile. So that electrophile will attack at ortho position. Though para product is formed to some extent, but because they can form intramolecular hydrogen bonding, that's why ortho product is major product. Okay, so that's why this is formed as the major product in this particular reaction. Okay, great, no doubt. Okay, so a small amount of para isomer is also formed. Okay, so why ortho is the major product? Because you can say that this is phenol and this is CHO, so they form intramolecular hydrogen bonding. That makes it more stable. But in case of para, there is no intramolecular hydrogen bonding. See, 1, 2, 3, 4, 5, 6. 6-membered ring is formed, and 6-membered rings that can cause chelation, so it will become stable. That's why ortho product is major product. Para is formed to small extent. Okay. Now, instead of chloroform, if we use carbon tetrachloride, instead of same reaction, but now instead of chloroform, we use carbon tetrachloride in the presence of sodium hydroxide. Again, NaCl and water is removed, and the product formed in this case is sodium salt and CCl3. Instead of CHCl2, we get CCl3. Now, 3 moles of NaOH. So 3 NaCl are removed and we get 3 Cl are replaced by 3 OH. And then when 3 OH groups are on the same carbon, again water is removed and we get COH double bond O, means COOH, and on acidification we get salicylic acid. So with chloroform we get salicylic, and with carbon tetrachloride we get salicylic acid. Okay? Yes. No, bonding of ions, or it is not like that. If two polar groups are present in the same molecule and we get ring type structure. Yes, you can say if there are didentate ligands, even then if in any molecule, if ring type structure is formed by any type of bonding, right, that is called chelation. Okay? Chelation means ring type structure formed by bonding. Like say in this case you can say hydrogen bonding is formed and we get 6-member ring. Okay? And in this way it becomes stable. Okay? So this is Raymond-Diamond reaction. Now come to Colway's-Schmidt reaction. Or simply we can say Colway's reaction. Yes, Sahil, you are right. Say in PtEnCl2 it is like this. So this is a ring type structure is formed with platinum. 1, 2, 3, 4, 5, right? 5 or 6-membered rings are formed. So that is called chelation. Okay? It is didentate ligand. But let us focus on next question, that is Colway's reaction. So in this reaction, phenol react with CO2 in again basic medium, okay, at 400 Kelvin and 4 to 7 atmosphere pressure. Atmosphere pressure. So first of all, in sodium hydroxide, phenol is converted into sodium salt. Now tell me, CO2, is it electrophile or nucleophile? And how can we justify that it is that particular kind? Yes. CO2, is it electrophile or nucleophile? Yes, tell me fast. Very good. It is electrophile because CO2, this carbon is attached to more electronegative oxygen. So carbon has positive charge and oxygen has negative charge. Because this carbon has positive charge and because pi bond is formed between two atoms having different electronegativity and carbon is less electronegative, that's why this is an electrophile. Okay, so CO2 is an electrophile. So when it attack, first of all we get sodium salt of salicylic acid, sodium salicylate, and on acidification we get salicylic acid. Is it visible? Yes. So we get salicylic acid as the product. Okay. So what would happen actually? Say, what is the mechanism of this reaction? We have phenoxide ion. Now CO2 is there, and carbon has partial positive, oxygen has partial negative. So what happened? It goes like this. This pi electron attack on carbon and this pi bond shift towards oxygen. So in this way we get this is the product form. Wait for some time, please. Is it visible? Because light will come after 5 or so minutes. Don't worry. Oh, sorry. No. No. Wait for some time, please. No. नेट ऑन कर दिया ना इस द मोबाइल हाँ तो चलिए वहाँ टेस्ट था चले क्या बोला है? Okay, tell me, is it visible to you? Hello guys, is it visible? Oh yes, light. Okay brother. Okay. So now, say we have this type of product. Now this H, because this is not aromatic, this phenoxide ion is aromatic in character. This, when CO2 attack on it, its aromatic character is destroyed. To regain or to retain its aromatic character, this hydrogen H plus ion shift takes place. H plus ion shift. And when this H plus ion shift takes place, we get this product. Okay? And on acidification, we get salicylic acid. Now keep in mind, phenol will not react with CO2. Phenol will not react with CO2 because CO2 is a weak electrophile, and that's why this weak electrophile will not attack on phenol. But when sodium phenoxide ion is formed, you know, phenoxide ion is more activating, therefore weak electrophile can attack on sodium phenoxide. Okay, that's why first phenol is converted into sodium phenoxide and then CO2 will attack. Got it? Yes. Any doubt up to it? Okay. So this is Colby's reaction. Okay. No doubt. कोई शक नहीं. Great. So this is always Binet reaction. Sodium phenoxide, that is attacked by carbon dioxide, which is a weak electrophile at 400 Kelvin and 4 to 7 atmosphere pressure. So we get sodium salicylate, and on acidification we get salicylic acid. So this is Colby's reaction or Colby's Squinet reaction. So by using this we can prepare aspirin. Next reaction of salicylic acid. So salicylic acid, when treated with acetic anhydride, tell me which type of reaction takes place in the presence of concentrated H2SO4. What is the name of this reaction? First tell me. What is the name of this reaction? Okay, Harshit, good evening. You are late. Acetylation reaction. Okay. Any other? That's okay, but general. What is the general type of reaction? It is acetylation. You know, you are right side. But in general, what is the type of reaction? Yes. Say, we have phenolic group as well as carboxylic and treatment with acetic anhydride. So this is an example of esterification. Even acid chloride can be used. Acid chloride can be used. So you know, H plus from phenol and OCOCH3 from acetic anhydride. So products formed are OCOCH3 along with acetic acid under completely anhydrous condition, because we use concentrated H2SO4. Condition should be completely anhydrous, because if there is small amount of water, this can be hydrolyzed back to the salicylic acid. Okay, so 2-acetoxy benzoic acid. This is 2-acetoxy benzoic acid, and this is the formula of aspirin. Yes, what it is? You know, aspirin has a medicinal value. So, what is the use of aspirin? Tell me. What is the use of aspirin? Yes. It is used as fast. What is the use of aspirin? You know, it has medicinal value. So what is the use of aspirin? Fast. To reduce fever and headache. So it is used as, keep in mind, analgesic, to relieve body pain, or we can say to relieve body pain or headache, and it is also used as antipyretic, to reduce fever. So keep in mind these two words, analgesic and antipyretic. Pyretic, पता है, pyre means heat, fire. Okay, pyrolysis, breaking by heating. Just like that, it is antipyretic, means to reduce the fever, and analgesic to reduce body pain. Okay, any pain, it may be headache. Okay, yes, right. Right, but right. Even aspirin has a use as a blood thinner. So whenever there is chances of heart attack, we can give aspirin because it is acting as blood thinner. It can remove clots. Okay. Side effects, because it is blood thinner. Okay. So if there is a chance of heart attack, then it's okay. Okay. But if otherwise, if blood become thin, then clotting is difficult to take place. Okay. Because when there is a cut, it should clot easily. Okay, means instantly. But if we use aspirin and blood is thin, clotting is very difficult to take place. Okay. Then next is aspirin with phenol and salicylic acid with methanol. Yes, what are the products formed? Write down the products formed. Phenol in the presence of POCl3 and methanol in the presence of HCl. Refluxing with HCl. Yes. What are the products formed? Again, reaction is esterification. Okay. Because it can act as phenol as well as carboxylic acid. Okay. So what are the products formed? Write fast. School la dekha mere karna hai. मुझे पता है सर नहीं दिमाग चल रहा अगर कोई बेटा अपने आप करो है ना. Okay. Okay, so you have to tell me that phenol will react with OH or COH, or methanol it will react with COOH or OH. Yes. Very good. Because this is alcoholic part, so it reacts with carboxylic part. Okay, good, Ashish, Swati. So these are the products formed, right? So this is phenyl salicylate and this is methyl salicylate. This phenyl salicylate is called Salol and methyl salicylate is the major constituent of oil of wintergreen. This is major constituent of oil of wintergreen. Okay, and this Salol, it is used full as intestinal antiseptic, and it is used in perfume industry. It is used in perfumery. Okay, perfume industry, because this is oil of winter green. It can also be used in mouthwash. It can be used in iodex. Okay, and can be used in perfumes. Okay, so Salol and phenyl salicylate is Salol. Methyl salicylate is oil, major constituent of oil of wintergreen, and third one is that 2-acetoxybenzoic acid, and that is aspirin. Okay, so salicylic acid is the primary substrate to prepare all this: aspirin, Salol, and methyl salicylate. Okay, right? Now next is Gatorade reaction. So in Gatorade reactions, here we use HCl along with HCl. Okay, so when HCl react with HCl in first, carbon and nitrogen is more electronegative, so pi electron transferred towards nitrogen, and in HCl, H is positive, Cl is negative. So in this way we get CHCl double bond NH. CHCl double bond NH. Okay, so phenol react with Cl, CH double bond NH in the presence of anhydrous AlCl3. So in the presence of anhydrous AlCl3, Cl negative ion is removed. So CH double bond NH positive. This as an electrophile will attack on the phenol. Okay, so when it attack, major product formed is this one, benzene ring OH CH double bond NH. Yes, that's right. So H and Cl is removed. The Cl is removed with the first it formed AlCl4 negative, then this H is removed. So overall HCl is removed, and then on hydrolysis, product formed is this one, that is called para-hydroxy benzaldehyde, para-hydroxy benzaldehyde, and this is called Gattermann's reaction. Okay, so in this reaction what we do, first we have HCl and HCN. HCl react with HCN to give this product, which when react with phenol in anhydrous AlCl3, we get this product, which on hydrolysis gives para-hydroxy aldehyde. Okay, so here HCl and HCN both are in anhydrous condition. There is no water. Okay, these are vapors of HCl, and HCN is in the liquid form, so that we get this product, which in anhydrous AlCl3 produces CH double bond NH cation, which act as electrophile and attack at para position. Any doubt up to this? Now, coupling reaction. Coupling reaction benzene diazonium chloride react with phenol, benzene diazonium chloride react with phenol in basic medium. pH is 9 to 10, weakly basic medium. In weakly basic medium, so we get para-hydroxy azobenzene, para-hydroxy azobenzene, because this one will give this one as electrophile, and this electrophile being bulkier will attack at para position of with respect to OH, and we get para-hydroxy azobenzene. This is actually azodye and is of orange color. Okay. Okay, done. So this benzene diazonium chloride is stable only in ice cold solution, means temperature is same as 273 to 278 Kelvin, and that is attained by placing the beaker in ice bath by placing the beaker containing benzene diazonium chloride in ice bath. Okay, so in this way we get azo dye, and this particular reaction is called coupling reaction because two molecules couple together, phenol and diazonium salt. Now, condensation with phthalic anhydride. Condensation with phthalic anhydride. What is phthalic acid first? Yes. What is phthalic acid? Tell me. What is phthalic acid? Anyone who can answer? Phthalic acid. Yes, anyone? Phthalic acid. Very good. It is dicarboxylic acid. So say if COH groups are at ortho positions, then it is called phthalic acid. pH is silent, okay? Phthalic acid. And if COH groups are at para position, means benzene 1,2 dicarboxylic acid. Phthalic acid is benzene 1,2 dicarboxylic acid, and this is called terephthalic acid. Which is benzene 1,4 dicarboxylic acid, right? So to prepare phthalic anhydride in the presence of concentrated H2SO4, H and OH is removed and we get this product. And H2SO4 concentrated is dehydrating agent, so we get phthalic anhydride. Okay, so this phthalic anhydride, when phenol is heated with it, see, okay, I will remove it. This is the method to prepare phthalic anhydride. Now when phenol is heated with this is phthalic anhydride. When phenol is heated with phthalic anhydride, by adding few drops of concentrated H2SO4, then water is removed and we get this product, and this is called phenolphthalein. Phenolphthalein. This is called phenolphthalein, and you know it is used as indicator in acid-base titration. That you all know, and this reaction is called Phthalic reaction. Right? So this whole thing, condensation of phenol with phthalic anhydride, and this reaction is called phthalein reaction. Okay? Okay, so we have 10 minutes. So we will do Lieberman's nitroso reaction. So in phenolphthalein it is a weak acid. In acidic medium it is colorless. In basic medium it gives pink color. Okay. First tell me, do you want to know how this change in color takes place? The mechanism behind it? Are you interested? Or we will go to the next question. Next reaction. Yes, tell me, are you interested? Only Ashish is interested. Okay, so yeah, so see what happened. Actually, you know, this is phenolphthalein. Now, in acidic medium, it exists like this only. So, in short, we write it like this HPH. Okay, and this is called benzenoid form of phenolphthalein. This is called benzenoid form of phenolphthalein. Okay, now when we add sodium hydroxide, then what happened? First of all, one of the it forms sodium salt. Sodium salt of phenolphthalein is formed, and then it gives this one and this form is formed. This is quinonoid form of phenolphthalein. This is benzonoid form of phenolphthalein and this is quinonoid form of phenolphthalein, and it is represented as pH negative. Okay, and this benzenoid form is colorless and this quinonoid form is of pink color. In basic medium it becomes pink, and in acidic medium it is colorless. Right? So this is the mechanism behind the color change. Okay. In acidic medium it exists as benzenoid form and that's why it is colorless, and in basic medium it is in the form of quinonoid form. It is in quinonoid form, that's why it is pink in color. Okay, done. So now Lieberman's reaction. So Lieberman's reaction, when phenol we have phenol, it is actually test for phenol. Okay, so phenol is treated with sodium nitrite in the presence of sulfuric acid. So you know, when sodium nitrite we have in the presence of H2SO4, tell me what is the product form? Sodium nitrite along with H2SO4. Yes. What is the product formed? When sodium nitrite react with but I have class daily from 8 to 9. Sorry, 6:30 to 7:30. Oh my God. It is around what, 8? Okay. Yes, it's fast. We are running short of time. Tell me fast. What is the product formed when sodium nitrite react with H2SO4? Very good. Yes, evening. Sodium sulfate along with HNO2. This HNO2 is actually HONO. HNO2 is HONO. So phenol react with HONO. Okay. So actually, you know, HONO HONO when react with phenol, para-nitroso phenol is formed. We get para-nitroso phenol. Okay, and on rearrangement, it is like this. Okay, means double bond O, double bond N OH. Okay, this is again quinonoid form. Quinone is formed. Okay, on rearrangement. Now this quinone will react with another molecule of phenol. So when they react, again water is removed, just like here, this H and OH. Okay, so we get this is the product formed, and this is called indophenol. Which is red in color. Means when phenol react with sodium nitrite in the presence of few drops of H2SO4, then it turns red. It turns red. This is the mechanism behind it. Why it turns red? Because of the formation of indophenol. First, sodium nitrite react with sulfuric acid to give nitrous acid. This nitrous acid will react with phenol. We get para-nitroso phenol, and this para-nitroso phenol when rearranged we get quinone, and this quinone when react with other molecule of phenol, whole thing attack at para position because of steric hindrance, and we get indophenol, which is of red color. Okay, and this thing we are not able to write below it, so better to remove all this. So in basic medium, this H plus ion is replaced by sodium, and water is removed. Sodium salt of indophenol is formed which is blue in color. So what is Lieberman's nitroso reaction? It is a test for phenol, that when phenol react with sodium nitrite and H2SO4, its color becomes red, and when sodium hydroxide is added, after that it turns blue. So if it takes place, it is a test for phenol, and that is called Lieberman's reaction. This red color is due to the formation of indophenol, and in basic medium, in the presence of sodium hydroxide, we get sodium salt of indophenol, and which is blue in color. So this is whole thing about Lieberman's reaction. So that's all about phenol. Thank you very much for watching this video. Bye. Jai Hind, Jai Bharat. Bye bye.